Good evening, students. So today we'll start with the next topic, which is Coulomb force between charges in terms of their position vector. Earlier we had a discussion on Coulomb's law in vector form, but today we'll be discussing Coulomb force between charges in terms of their position vectors. So you have already studied position vector in your class 11th, that the vector which is basically explaining the position of a vector with respect to a particular frame of reference is known as position vector. So in this derivation we'll be taking position vector into picture. So for that we have a diagram. We have taken a frame of reference. This is X, this is Y, and this is Z. Of course, this is O is your origin. And here we have two charges. One charge is Q1 and the other charge is Q2. Suppose this is point A and this is point B beta. And I have already explained to you yesterday also and day before yesterday that we are having two forces here. One is F12 and other is F21. F12 is the force which is acting on first due to second, and F21 is the force which is acting on Q2 due to Q1. So as you can see here, the arrows also, the point A here, the arrow is towards that side. That means this force is acting on the particle A because of particle B. And here the direction is this side, towards this side. So which means this is the F21 force. So F21 force is the force acting on Q2 due to Q1, right? And I already explained you yesterday that this R12, this sign is cap, of course, R12 cap and R21 cap. And I've explained to you that this is the unit vector which is represented like this. So R12, you very well know, is the distance or the unit vector from position 1 to position 2. That means position from the charge Q1 to the position of charge Q2. And R21, you very well know, of course, from Q2 to Q1 distance. So here one more vector is there. This is R1 vector, which is actually explaining the position of point A, or you can say the charge Q1 with respect to origin. So OA vector is equals to R1 vector basically here, and here at point B, of course at Q2, from O to B, the position vector is R2 here. So now we'll start with the derivation. Here it says Coulomb force acting on Q2 due to Q1 is given by. We've already studied this thing, students. The force F21 is 1 by 4 pi epsilon naught Q1 Q2 upon R square into R12 cap. We had a discussion on this day before yesterday. I believe you still remember. Here I haven't mentioned R here. Here I'm using position vector. So here from point, of course, I'm taking here AB magnitude, but I'm taking here this value AB. So now we'll calculate the magnitude of AB. So for that we'll be using triangle law. Remember triangle law of your +1 class? I'll recall that thing for you. So suppose if this is your R2 vector and this is your R1 vector, and the direction is this. Of course, this is O point and this is your A point beta, this is your B point, and direction for this, if I'm taking which force? F21 force, which is acting towards this side, right? So I will apply triangle law on this, and triangle law says that you can add the two vectors which are acting on the same side. So O to A to B, that means the same side. Then it should be from B to O, but it is from O to B. That means this is the opposite side. So apply triangle law. Triangle law will be OA vector plus AB vector is equals to OB vector, which means AB vector will be equals to OB vector minus OA vector. This is not mentioned in the book, so that's why I'm solving it right now here. Okay, so let's move back here. This is AB vector here, and this is your OB vector. See, OB vector is R2 vector and minus OA vector is your R1 vector beta. So that's why in the book it's written AB vector is R2 vector minus R1 vector. And for like simplifying this thing, if you don't want to write R2 minus R1 vector again and again, you can simply write it down with the subscript like R12 vector. So we will be writing AB vector as R12 vector. Now we will substitute this value in the equation number 1 here. Okay, so the equation will become F21 vector is equals to 1 by 4 pi epsilon naught Q1 Q2. Here I have substituted this value. Okay, so this will be R12 square R12 cap. But they are saying R12, this R12 magnitude is equals to R2 minus R1 magnitude, right? Also, we want to calculate the vector R2 vector minus R1 vector.